Well, first off, I would like to start off by thanking you for taking the time to attend our presentation today. My name's Lance Zurich, and today we're going to take a brief look at two special curriculum-based sets from Studica that were designed for introducing students in middle school, high schools, and even homeschool environments to introduce them to the fundamental principles behind mechatronics. Now, each of these sets that we're going to be looking at are designed for conducting a project-based class. And this is essentially where students are going to be required to design and build a series of original prototypes, all based upon their own research and activities. Each of these sets includes special standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. And you're going to hear me mention his name a couple times today. So, anyways, today we're going to start off where so many of these technology-focused presentations for education seem to start off these days, and that's with talking about the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for better STEM education in the schools, and of course, STEM is an acronym which stands for science, technology, engineering, and mathematics. I assume that's something we're all familiar with. But when you hear someone talking about this, what they're essentially talking about is that there is an urgent need to prepare our students with the background that they're going to need to successfully compete in the job market they're going to be graduating into. Now, in the employment market that once greeted our parents or our grandparents, a good work ethic, a strong back, and being able to take direction on might have been enough to land a good paying job where many of the technical aspects could be learned along the way. But now students have to really be prepared to enter a world that is increasingly focused on things like programming and automation and all sorts of rapid advances in every aspect of technology. Because of this, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. And this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage we enjoy, things like the tablets and the smartphones that we all use daily, these things were all created because of individuals who helped to make those advances. Now, when you look around the globe, you see countries like China and India and so many others making major strides in developing new technological advances. And while they're doing this, they're preparing their own students to take place in the future workforce. Here in the United States, of course, we also need to prepare the next generation of graduates with the skills and the mindset and the habits that they're going to need that will enable them not only to secure jobs, but also to take their place and be part of that next wave of advancements that we rely on to stay competitive on the world stage and, of course, to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology focused programs, I'm not going to go into that anymore, but instead we're going to go move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, or IoT, and computer science, all of which are, of course, extremely important subject areas for students to be exposed to, and all skill sets that are very highly prized in today's technology-focused job market. But just how prized are those skills? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who, of course, prepare themselves by pursuing the proper post-secondary coursework, of course, they need to start developing the habits and this career focus as early on in their education as possible, in high school, if not even in middle school. The dilemma for educators while all this is going on, whether they're in the classroom or even in the homeschool environment, is finding ways of introducing this type of subject matter to students in a way that will get them interested and involved in the learning process, and not where they're just memorizing obscure facts or ideas just to, enable them to take a few tests and then promptly forget what they know. No, instead, to really help students to be successful and to encourage them to really consider pursuing further education in subject areas like this, Educators need to be able to present the material in a way that makes it relevant, which means, of course, answering that question that students always have, which is, why do we need to know this? You need to give them examples of why this is important. And it also needs to be engaging in a way that holds students' attention better than rote textbooks and lecture presentations do. And it really has to be something that has visible real-world applications and where students can get involved in doing things hands-on. So it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject, these were created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, of course, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF. There will be directions for downloading it included in each box. And this is a free document with the purchase of each set. The curriculum is designed to enable, or excuse me, is designed to align to the most widely accepted academic standards currently in place in the United States. And the curriculum was also designed for offering a project-based learning program, as I mentioned before. And this means that solving the problems that arise in each of these units will require the students to be actively involved in the research phase, the design phase, trial and error experimentation and activities, as well as the building of actual working prototypes that will provide the required answers. And students aren't going to be asked to do this alone. No, they're going to be asked to work in small groups or teams of 4 students per group. And this will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And when we talk about things like soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, uh, there is also these sets will include all of the physical materials. Everything you're going to need is going to be included in there. We have software that's used for this. There used to be a cost for it. There no longer is a cost. We will send you links to the software when you purchase this. So pretty much when you buy these sets, it's going to have all the materials and the curriculum, everything you need to enable you to address all the design projects presented during the course of the curriculum. Now, the curriculum is designed to enable teachers of all sorts of backgrounds, and this means even teachers from non-science or technology-focused disciplines to be able to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. And I know we see this historically, is that a lot of times the teachers who end up teaching STEM programs, robotics programs, what have you, may not always be the teachers who have the science background per se. It may even be someone who's working in physical education or what have you, but where you want to be able to have enough things that, as we say, pack your parachute, so that again you have all the material you need to be comfortable in delivering the class. And we've tried to do that here. And the curriculum itself is designed to be clear and easy to follow, providing a clear roadmap for student learning. There are various supplemental materials that are included, both in link form throughout the curriculum and also at the end of each unit that the students are going to encounter. And there are also special tutorials on familiarizing students with the building system that they're going to use to address the projects that are presented in each of these units. The units in the curriculum are designed as a series of projects. Now, each of these projects is presented to students in the form of an engaging real-world style scenario. And it's where students have to work together in small teams. Again, as I mentioned, teams of 4 students per group. And they're going to work together to create a solution to whatever the problem is that they're given. The project units each contain embedded academics, and at the end of each of the units, students are going to be required to make a formal presentation of the prototype that they have created to address that particular scenario, that problem, so to speak. They have to do a formal presentation, as I mentioned, of the prototype, and explain the reasoning behind why they constructed the prototype the way they did, why they made the choices they did. There's a technical literacy task driven by each of these projects. Now, as students work to address each project, they're going to acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through carefully designed enabling activities. And again, as required by each project, students are going to be asked to create original prototypes. Of course, any required programming-based solutions, the students are going to have to create that as well. And they will also need to maintain detailed documentation during the entire process. Now, as I mentioned his name a few times during the presentation, the curriculum that accompanies each of the mechatronics program sets was again created especially for Studica by Tom White. Now, Tom's a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs both for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, the standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K to 12 and standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. Now, when students ask a question like, why do we need to know this? It's usually because the subject matter that they've been presented with might come across as too abstract to ever be useful in their lives. I know there are subject areas that I dealt with that felt that way to me. But instead, with this project-based approach, students instead get to see firsthand why these things are necessary and important and why they're useful. The concept of working again in these small groups to solve the project problems that they're presented with, again, helps students to develop the high demand soft skills that employers look for. Again, things like communication, analytical skills, quantitative skills, flexibility, adaptability, problem solving, etc. Now, in this project-based format, all of the subject matter is integrated. And what I mean by that is things like math are integrated with the reading, which is integrated with the writing aspect, and so on. And this kind of approach is really ideal for STEM education. And also because of the manner in which students must approach each of the projects being put forth in the curriculum. Again, we're talking about the research they have to do, the testing, and the group give and take to provide just a few examples. Because of this, it allows for a much deeper exploration of problems than traditional teaching methods, again, lectures and reading texts and what have you. It provides a much deeper exploration of the problems than traditional teaching methods might allow. Now, the projects presented in each unit are designed so that if you have several groups working on the same project, you should see variations in the types of prototypes and solutions that are being presented by your students. And this can be because of differences in creativity, differences in research and approaches taken by each group. But in any case, what this allows, it allows students to see firsthand that problems can have many different answers, and that often there is not only one right answer, but that there can be many. Each project in the curriculum presents students with the opportunity to plan, organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects, research that is utilized in the design, prototyping, testing, evaluation, and redesign phases of each solution. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. The team approach, as stated before, helps promote soft skills, again, such as communication, the ability to work well with others, and leadership. And the sets themselves are easily scalable. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. Again, each set contains materials for 4 students. And once again, everything you need to conduct the program is included. So access to the free curriculum download is included with the purchase of each set. Again, we're going to send you links to download the software with each set, and also included are all of the building materials which students are going to use in the creation of their prototypes. And since we haven't talked about it, these materials are from the unique Fisher Technic building system, and among the components included in each set are two robotics controllers and two power supplies. Of course, many of you may not be familiar with Fisher Technic, so I'm just going to take a second to provide you with a little bit of background. Fisher Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed primarily to stack, the Fisher Technic system was created with more of an engineering mindset. The core building block in the Fisher Technic system was designed so that it allows attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. You can see that in the photo. And the system also includes a wide selection of very specific parts, different variations of gears, girders, sensors, and so much more. And this allows technical builders to address equally specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fisher is known as the inventor of synchronized flash photography. That was in 1949. And he's also known as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to anchor heavy objects to walls. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components that are used in automobile manufacturing. And they also provide, I should say, consulting services related to high-end automated processes. So, with all that being said, let's begin looking at each of the two individual sets, and we're going to start off with the Studica Introduction to Mechatronics program set, or for those of you who like to use acronyms, you could call it SIMP. The set is designed to help provide a well-rounded introduction to the core concepts behind the subject of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. The curriculum itself contains enough activity and material to fill approximately 45 academic hours. And as such, we recommend this program set either for insertion into regular related class activities to be used as a short class unto itself, or you could use it for after school program use, or of course, for homeschool use. The curriculum created for the sets is standard focused, again, using the academic standards most widely recognized in US-based education today, and it is designed for offering a project-based program. The set again is designed for use in middle or high school classes, or again for addressing these same grade levels in a homeschool environment. The set itself contains a collection of over 700 Fisher Technic building components, and this will include everything from gears, wheels, axles, blocks, sensors, and much more, as well as the two robotic controllers and the two power supplies. And again, we will provide a link to the software that's used for this. So pretty much you will have everything you need in one place. The curriculum for the Studica Introduction to Mechatronics program set consists of 6 project units. And they are sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following topic areas that will come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flowcharts, working with the software and the robotic controllers, working with sensors such as the digital switch and the digital phototransistor, learning about open loop and closed loop programming, as well as digital branching, excuse me. Analog sensors such as the photocell LDR, analog branching, additional analog sensors including the NTC resistor, and the potentiometer. Now, before we go further into the structure of the curriculum, we're instead going to take a quick look at what's covered in the second set. Now, the second set is titled the Studica Teaching Applications of Mechatronics Program Set, and if you want to use an acronym, you could call this one STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set comes with access to a free downloadable 400 plus page curriculum document entitled Mechatronics Applications, again written by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, are designed to fill approximately 180 academic hours. So what we're talking about is essentially 4 times the amount of academic hours as were covered by the previously discussed set. Now, as such, this set can really be seen as either a more expansive version of the material uh, touched on in the previous set, and it's really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days per week, or the equivalent each week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or of course for addressing those same grade levels in a homeschool environment. The materials in this set consist of a selection of over 1,200 Fisher Technic building components. And again, this is going to include a wide variety of blocks, sensors, gears, axles, and much more. And again, you get the 2 robotic controllers and the 2 power supplies. And again, we also provide the links to the software. Now, there are twice as many project units included in the Studica Teaching Applications of Mechatronics program set as with the previously discussed set. And this will include units on sketching and documentation, simple machines, mechanical systems, basic electricity, as well as project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And this will include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flowcharts, using the programming software and robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming, digital branching, learning about logic gates and combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. So now that we've had a look at how each of these sets differs and the specific subject matter that's covered by each set, now we're going to look at exactly how the curriculum itself is structured. Now, both versions of the curriculum will share the same format when it comes to the structure of how materials are presented in each unit. And as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is designed to be turnkey. And what I mean by that is that each unit is designed to clearly spell out everything being addressed, and again, to provide tutorials and other information as the topics come up. So this was designed specifically to enable teachers from all kinds of backgrounds, again, including those teachers who may come from a non-science or a non-tech focused background. Well, it's designed to enable teachers to be able to review the material and quickly become comfortable with delivering it. Again, by reviewing it, everything is going to be spelled out for you. There are links to various things as they come up again. So trying to again pack your parachute for you. Each unit presented in the curriculum for each of these sets will include areas on the following: an introduction, the purpose of the project, the concepts, an outline of what's going to be presented, the standards that are being addressed, assessment rubrics, an essential question, the student scenario that I talked about before, the real world style scenario where the problem or the project is being presented. There's a daily plan, vocabulary, and resources. So we're going to take a look at each of these sections a little bit closer. Now, of course, the introduction purpose of the project is just as you would gather from that name. This is the section that provides a brief description at the top of what's going to be explored in the coming days and the coming activities. And it also spells or seeks to spell out to students why they're learning this material and why it's important for them to know. The next section focuses on the main concepts to be addressed in the particular unit, and these can be thought of as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that's going to be essential for them to understand and utilize not only today, but also this is the material that they're going to draw on as they move forward in STEM fields of study and if they choose to pursue it further in STEM-related careers. Following this, we encounter the outline. In this section, we drill down more specifically to what's going to be addressed in the particular unit. Now, as the example that I'm sharing on the screen right now is taken from a unit that addresses aspects of programming, you're going to see that it's going to touch upon areas such as the methods for writing programs, which includes things like flowcharts, word problems, etc. It's going to talk about things like program characteristics, for example, open or closed loop, branching, whether it be digital, analog, subprograms, and so on. The next section of each project unit focuses on the specific academic standards that are going to be addressed in the unit. And as you see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, along with general rubrics for literary tasks. Next, we come upon the essential question. This can be thought of as the big picture question that will be focused on in each of the smaller individual activities, and of course, all the aspects of the larger project, which students are going to be asked to complete in this section. Next, we see the student scenario, and this is where the specifics of the project to be addressed are really spelled out. And it's again presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved by the creation of some sort of a device, a machine, a mechanism, what have you. Now, as I mentioned before, students are going to be asked to work together in small teams or groups of 4 to craft the answer to this challenge. Solving this problem is going to require each team of students to design a unique and original answer, which once again will usually take the form of a working prototype. And they also, of course, have to design whatever kind of programming may be required. So just to provide an example of what we're talking about here, if you look closely at the student scenario being shown on the screen right now, you will see that the project in this unit has each group of students taking place on a design team employed by a firm that manufactures garage door openers. Now, in this particular scenario, students are being required to design a specific type of control system for this new line of garage doors. The manufacturer's requirements are spelled out here, and they have various things that they need to include, such as the use of limit switches, meeting certain safety codes that are required for, and requiring a method for sensing if anything is in the way of a closing door, as well as the incorporation of an automatic light. So all these things are spelled out. These are things they need to include. So again, each team of students will be tasked with creating both a unique and original prototype. In this case, of course, it's going to be a garage door opening system. And they, of course, also have to create the programming needed to control the prototype. Now, as they move through the challenge being put forth in this scenario, each student team is going to be required to document the entire process, and that means both in a design notebook and a digital engineering journal. They have to notate all of the research that they do. They have to notate all of the trial and error experiments that they conduct. They have to keep copies of all the design sketches, any revisions they create, and so on and so forth. Now, at the end of each of these project units, as I mentioned before, each team of students is going to be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and their programming in action, as just as they would be required to do for an actual employer, or client in the real world. So next up, the next section we encounter is the daily plan. And this is the section that spells out clearly, both for students and for teachers, what's going to be expected of students. It spells out how the teacher is going to conduct the day's classroom activities and what specific subject matter is going to be covered. Now, some days may include discussions, other days may involve research, or might even be the building of small projects that will help provide the building blocks, so to speak, to students that they're going to draw on to complete the larger projects that they're being tasked with. Now, in short, you can think of the daily plan really as a roadmap designed to keep everyone, again, students and teachers, all on the same pathway. Now, you also see too that as different aspects are addressed in each day's activity, such as what is going to be required in a design notebook, or how to use the control software, or working with the controllers, or with flowcharts, or whatever it might be, that as these things come up, there are links to sections which will provide further instructions and background information on each of these areas. So again, if somebody's not familiar, you click on the link, it's going to help explain it to you. Now, at the completion of each unit after the last day of the daily plan, there is a section containing vocabulary, and this can be both important words and also important terminology that are introduced during the project unit. And there's also usually a selection of useful resource materials. And these resources could be a mix of different things. It could be carefully vetted websites, could be video links, or it could be PDF documents, PowerPoints, what have you. It's really going to depend on the unit. Now, besides the project units, each of the curriculum documents also includes a special tutorial section, which was designed to educate both students and teachers about how to use the Fisher Technic building system. Now, this is going to include information on how the parts fit together using the pin and groove assembly method that I mentioned, how to identify the different types of parts from the various types of girders and blocks, or the different types of axles, gears, rivets, etc. And students are also going to get to build a very basic sample model just to help them familiarize themselves with the building system before they move on to the larger projects. And as learning about and maintaining proper documentation is one of the areas we stress in the course of the curriculum. You've heard me mention digital engineering notebooks and things of that nature a few times. There's also a section that's going to detail just what defines what's required for each type of documentation listed on the screen now. So this way, again, filling in all the details. And as the process of conducting one of these more open types of project-based learning activities may be new to many teachers, there's also a section that discusses project-based STEM education and its benefits. And that essentially completes our overview of the two sets. So we're going to quickly review the contents and purpose of each set, but this time I'm going to talk about the pricing. So first up, we have the Studica Introduction to Mechatronics program set, which again is designed as a standards-focused project-based introduction to the core concepts of mechatronics. Again, it includes the highly detailed 242-page curriculum document entitled Mechatronic Fundamentals, written by noted educator and STEM expert Tom White. This curriculum, again, when used in conjunction with the building materials in this set, will provide teachers with enough activity material to fill approximately 45 academic hours. Again, because of this is designed for educators who wish to offer either a shorter class on the material, who wish to incorporate it into after-school programs, or, of course, to use for homeschool use. The teaching material is designed for use in middle and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics at these grade levels. And the physical materials included in the set will include a selection of over 700 components from the Fisher Technic building system. Again, blocks, gears, sensors, much more, as well as 2 robotic controllers and the power supplies. These materials will again be used to construct the mechanical prototypes being addressed in each project of the curriculum. And again, we will provide a link for the software. Each set, again, is designed for teams of 4 students at a time, with pricing starting at just $699 for a single set, and discount classroom pricing for groups of 20 students and up is available by quote upon request. Next, the Studica Teaching Application of Mechatronics program set is designed for use as a more in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again written by our expert, Tom White. Now, when used in conjunction with the building materials included in this set, this curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Again, 4 times the amount of teaching material in terms of academic hours as is used in the first set. And because of this, it's designed specifically for those teachers and homeschoolers who are able to dedicate more time, essentially a daily class period of 50 minutes per day, 5 days a week, or the equivalent to this subject for a full academic year. So I know sometimes some people may choose to do it, break it up in 2 days or do one day where you just do a lot of mechatronics. But either way, again, you have to kind of budget in that 50 minutes a day, 5 days a week. The set is designed for use again in middle schools, high schools, and as well as home schools, addressing the same grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic building system. Again, sensors, blocks, gears, rivets, axles, 2 robotic controllers, 2 power supplies. We provide the link to the software. Again, it's designed for use by teams of 4 students at a time. And pricing for a single set on this one starts at just $7.99 per set. And again, discount classroom pricing for 20 students or more is available by quote upon request. Now, as I've mentioned the software several times, what we're talking about is Fisher Technic RoboPro. It's graphic programming software. It's designed specifically for use with Windows 7, 8, or 10. It does not work for Chromebooks, unfortunately. It's when I talk about graphic programming software, what I'm talking about is that it essentially uses a flowchart style design where it uses various icons that students arrange and link to create the programs being used for each model. And because of this, it's really ideal for teaching the fundamentals of programming to users of all levels. Now, as I mentioned, the software we used to charge for it, it's now absolutely free. Aside from the fact that I have a download link there, we will now send it to you directly. So don't even worry about this. So, on that note, if you do have any questions, you may have noticed on the Zoom toolbar there is either a webinar chat window or a question and answer Q&A window that are available. So, if you do have any questions, you can feel free to type them in. I will go, I will keep things moving. I will go once, go twice, and if you're not ready to ask a question now, you can always ask later because I'm going to provide information on how to get in touch with us. So, if you're ready to take the next step, whether it be getting a quote or if you'd like to speak to a dedicated educational representative in your state or, just to find out more about these 2 sets or any of the other educational products we offer, you can call us at the toll-free number 888-561-7521. You could also email us at either info@studica.com. That's info@studica.com. That's for general quote requests, the information, what have you. But if you do have any specific questions about anything that I've discussed today, or maybe something that you wish I would have touched upon, if you have any questions about Fisher Technic or the whole line of Fisher Technic education-focused solutions that we have, many other items besides the sets that we discussed today. So if you'd like to learn more about that, you can contact me directly. My email is up on the screen. That's lance.zurek. That's lance.zurek @studica.com. So on that note, we thank you very much for taking the time to attend today's presentation. We look forward to speaking with you soon. Have a great afternoon. Have a happy Thanksgiving week, and we look forward to hearing from you. Take care.